All right, so 6.4b lesson, area of a circle. If we were in class, we'd be working with this program called GeoGebra to take a look at what area, where it comes from, and how it came about. Okay, so Johannes Kepler, 1571 to 1630, tried his approach to define the area of a circle. He suggested dividing the circle into isosceles triangles and then restructuring them into a parallelogram. Okay, let's think about that. Do we know how to find the area of a parallelogram? Base times height. Hopefully you recall that from elementary school. Okay, so they give you a link here to look at, and you guys, it changes all the time. I just tested it out and it referred me to this link here, this link right here. So please take note of that. Okay, or you can type in the one that's printed on the PDF and then it'll refer you. I don't know how long it will keep up that link to refer you though. Okay, so this is the new and current link. Okay, so I'm going to kind of be going back and forth between this. Okay. All right, so we're going to cut the circle into eighths. It was done for me. Cut and paste the eighths into a long line. Turn the pieces opposite ways to create a parallelogram. Okay, so what you would end up getting if you cut these out would be something like this. Okay, wouldn't this be the radius? Wouldn't that be the side of one of the wedges? Okay, and then we turn them opposite ways. Okay, now let's think about this. Isn't this side half of the circumference? Which means this other side with it, both together, is the full circumference. That's something important to understand. Okay, now if you go to the next page. Okay, now we've got 10 wedges. 10 wedges. It says the figure to the left shows the same circle of radius 3 as the previous example, but this time cut in 10 wedges. How will this parallelogram compare to the one created with 8 wedges? Okay, so let me go back to this screen here. Okay, so I want to look at 6. Okay, so here's 6. Let me make the radius 3. Okay, so here's the 6 wedges. Here's the 6 wedges. Okay, now this next problem says that they want to go to 8 wedges. So I want you to take a look at this. And I want you now to take a look at this. Is there any difference that you're noticing? So 8 and 6. 8 and 6. Okay, I am noticing with 6, there is more empty space up here. There is more empty space. Okay, now with 8, watch what happens to that empty, whoops. Look at what happens to that empty space. It gets a little smaller. Okay, see how it hangs over that rectangle here? And isn't a rectangle a parallelogram? Okay, so that hangs over there, but it kind of fills in its empty spaces up here. You can think of it that way. Okay, so I'm going to put that the parallelogram, okay, take a look at these side lengths here and go back to this one here. Where is it? Sorry. Okay, so that has 8. Oh, and that one has 10. We haven't looked at 10. Sorry, guys. Okay, there's 8. Ooh, look at that. Okay, I'm seeing barely any white here, barely any white. Okay, so as you increase the number of slices, watch what happens. You seeing any white there? 12 slices? Ooh, look at that, 20 slices. That is pretty darn close to the area of a rectangle, isn't it? Okay, and that is 22 slices, and we can go all the way up to 36. It allows us to go up to. Okay, and there's no white left at all. Okay, and then look at what happens if we go all the way down to 4. There's a lot of hanging over. Okay, emptiness. Okay, it gets way more accurate. Your parallelogram gets way more accurate. All right, so let's start answering some of these questions. How will this parallelogram compare to the one created with 8 wedges? Okay, this parallelogram is more accurate. Accurate. Sorry, guys, I forgot to see. Accurate, since the curved lines form a straighter line. Okay. Will the area created by reorganizing the pieces be the same or different than the original circle? So if I take these wedges out and lay them out like this, the area of this is exactly the same as the area of that. Okay, so technically it is the same. It is the same, but it is difficult to approximate the curved edges once it's formed into a parallelogram. All right. So then you've already seen that live. Okay, this went up to 50. Mine didn't give me the option to go to 50. Okay, it wants us to highlight the circumference of the circle and highlight where the circumference is found in the new diagram. Okay, so let me get a highlighter. So here is the circumference in the circle. And then are you good with here and here would be the circumference in the rectangle / parallelogram? Okay. All right, explain why the base of the parallelogram is half the circumference of the circle. Okay, is everybody good that this half of the darker triangles would be half of the circle if you put all the dark ones together? Okay, the light ones up here are the other half. Okay, so it's very important to understand that. Okay, so the curved edge of the lighter shaded wedges make half the circumference, and the curved edges of the darker side and the darker curved edges make the other half. All right. What else I want to show you is this. Do you see that the radius is the side length of any one of these wedges? Okay. Highlight the radius in a different color. Okay, so we just did that. Explain why the height of the parallelogram is the same as the radius. The straight part of the wedges, straight part of the wedges are all the radii. You guys, radii is plural for radiuses of the circle. The straight part of the wedges are all of the radii of the circle. Okay, this is very important. Number 5. It says use the figure and what you know about the area of a rectangle to write the expression for the area of a circle. All right, so we know area of a rectangle is base times height. Okay, or length times width, but I'm going to use base times height. Okay, the B in this case is half the circumference. And the H is the radius R. Okay, so we're going to substitute. We're going to substitute something in for B and something in for H according to what we just said here. Okay, so if we have A equal BH, we've got A equal, instead of B, we're going to put in half C, half circumference. Instead of H, we're going to put in R. Okay, now, since C equal 2 pi R, since C equal 2 pi R, I'm going to replace the C. We want it to be in terms of one letter. We have C and R in here. So I'm going to relate the circumference with 2 pi R. So I've got 1/2 2 pi R, R. So this is, let me do a pink color. Okay, so half of 2 is 1. Pi R is pi R squared. That's where the formula for the area of a circle comes from. That's where it comes from. It's important to see where this comes from. I'm sure in elementary school, if you did anything with areas of circles, you were just told A equal pi R squared. Okay, well, that's where it comes from. All right, now that we know where it comes from, let's answer some questions on the following couple pages. All right, it says estimate the area of the circle in square units by counting. Okay, couple ways you can do this problem. I went ahead and looked at these chunks that were the same. Let's see. Oops, too far. All right, so I've got 1, 2, 3, 4, 5, 6. 1, 2, 3. So I've got 4 groups of 6 right here. That takes care of that. Okay, now I'm going to do this pink area here. This pink area. I just accounted the 4 groups of 6 as this area. Okay, so that pink area is 1, 2, 3, 4, 5, 6, 7, 8. 8 by 8. Okay, now do you see that I've got these little partials? Got these little partials, and you have to approximate, guys. Okay, so I've got, let's look at it this way. This one and this one probably make 1. Okay, this one and this one make another. And this one and this one probably make another. So I'm thinking that's 3, about. Okay, this purple's about 3. Okay, and we have the same thing up here. Let me double check. Yes, we have the same thing up here, same thing here, same thing here. Okay, so we've got 4 groups of 3. Okay, and every time I do this differently, honestly. All right, now these guys look to be a little more than half. Okay, this is about 1. This is about 1, this is about 1, this is about 1. So I'm thinking I've got another 4 groups of 1, a little bit more than that, but I'm estimating. I'm estimating by counting. Okay, so let's see what we've got here. We've got 24 plus 64 plus 12 plus 4. Okay, when I add these all up, 24 and 64 is 88. I get 104. And this is units squared. Now I know that's a little low because I know that these two together are probably 1.5. I'm thinking. Okay, so this is a rough estimate. When I did this before, I got 112. Okay, an estimate's an estimate. All right. So the area of a circle, pi r squared, we calculated on the last page. Okay, it says use this formula now to calculate this. Okay, well, let's look at the radius. 1, 2, 3, 4, 5, 6. The radius is 6. A equal pi 6 squared. Pi times 36. Okay, so leave it in terms of pi. The answer is 36 pi units squared. Now to calculate that to the nearest square unit, okay, let's go ahead and do 36 times 3.14. And we get roughly 113.04 units squared. Okay, I was close. I was close. Whoops, sorry guys, let me scooch that up. So I did 36 times that pi is 3.14. Okay. And then I found the actual area of this thing, calculating it to be this. I was close when I counted. Close. Okay. All right. Number 9. Calculate the area of each circle. Express your answer both exactly in terms of pi and approximately to the nearest tenth. All right, so exactly in terms of pi is here. And then approximately to the 10th is going to be in this column. All right, so the radius. The radius is, that says 3.5. This says 2.4, and this says 5 miles. Oopsies, I made a mistake right here, didn't I? This is not the radius. This is the diameter. Do not make the mistake I made. Okay, I'm glad I actually made that mistake so I could emphasize it. 1.2 inches. All right. So here we go. Let me get my pink pen going here. Area equal pi r squared. So area equals pi. Now r squared, this is 7/2. Well, 7 squared and 2 squared gets me 49/4 pi. That's my answer. 49/4 pi feet squared. Okay, area is two-dimensional. Please make sure you have the squared on the unit feet. Okay. All right, now popping that in a calculator, you're going to do 49/4. That's what you're going to do in the calculator. So you're going to do 49 times 3.14 divided by 4. And you're going to see to the nearest tenth, 38.5, and we're still in this feet squared. Okay, these are the same answers. These are the exact same answers. But this one's in terms of pi, leaving it exact. And this one is rounded, approximated to the nearest tenth using 3.14. All right, you can pause me and try the other two just like we did here and catch up with me and see if you've done them right, or you can hang with me. A equal pi r squared, pi 1.2 squared, pi 1.44. Okay, remember exact in terms of pi means keep the pi symbol. So 1.44 pi inches squared is your answer exactly. Cruising over to my purple color, you're going to have 1.44 times 3.14. And that comes out to be, this is roughly because we're approximating, to the nearest tenth, 4.5, and we are in inches squared. Okay, please notice that there is no pi symbol left in this answer, but there is in this one. Okay, all right. A equal pi r squared, pi 5 squared, 25 pi miles squared. That's your exact value. This would be 25 times 3.14, and that gets us 78.5 miles squared. All right, last page. Okay, these are challenging on this last page. Jury's still out. I'll be putting them on the test. If we were present in school, I would definitely have these on a test. Okay, I'll still think about it for this year while we're virtual. Okay, explain the difference in units for circumference and area of a circle. Okay, so circumference, this is important. You don't want to lose a point because your units are off. Circumference is a length. So just plain old units. Area is two-dimensional. So units squared. Okay, it's very important to understand you put a little squared on the units on area, but you don't on circumference. All right, you're given the area this time, and we're to calculate the radius. Okay, so we've got a equal pi r squared. 3.14 goes in for a. And guess what? 3.14 goes in for pi. So we're going to divide by 3.14. And we get r squared equals 1. What times what is 1? Okay, we're taking a square root right now, which we haven't really even learned that. But you guys understand that a number times itself is 1. That is 1. Okay, so 1 inch is the radius for this problem. All right, let me switch colors just so it doesn't run into the purple. I went over the black line. All right, so area equals pi r squared for this guy, 50.24 for the area. I'm popping a 3.14 for the pi. I'm going to divide by 3.14. Excuse me. And then I'm going to get r squared equals 16. Okay, well, we have to solve for r, not r squared. What times what is 16? The same number, 4. Okay, so this is 4, and we're still in inches. All right, number 12. Start with a formula, show your substitutions, and solve. Right answer in a sentence. Round answers to the nearest hundredth where appropriate. So we're rounding. We're not keeping pi in our answer. A certain earthquake was felt by everyone within 50 kilometers of the epicenter in every direction. Do you understand that 50 kilometers is the radius of a circle? Okay, you need to think about it like this. That's where it kind of goes out to, the earthquake goes out to. Everybody that's within 50 kilometers. So a equal pi r squared. Excuse me, guys. We're going to pop in 3.14 for pi, and 50 is going to be squared. Okay, so remember from 6th grade PEMDAS, we need to do exponents first, so 50 times 50, and then times 3.14. And I am rounding to the nearest hundredth where appropriate. Well, this came out pretty nicely. 7850. Remember, we're in squared units. Okay. All right, number 13 is a great problem. Okay, this is the one I usually have this on a test. Okay. All right, so a circular pond, 12 meters in diameter, is surrounded by a brick walk 3 meters wide. Find the area of the pond and find the area of the walk. Round to the nearest hundredth. All right, so let's find the area of the pond. Pi r squared. Okay, pi r squared, we're going to do round to the nearest hundredth. Okay, so pi 3.14. R of the pond, 6. Okay, so you're doing in your calculator 6 times 6 and then times 3.14, and that's roughly 113.10 meters squared. So that's the area of the purple pond. Okay. Now I want to find out the area of this whole, the pond with the walkway. So it's the pink, the whole thing. Okay, now be really careful. What is the radius of the pink circle? Do not say 3. Do not say 3. Okay, you have to think about half of that as well. So 9. Okay, so area of the pond and walk. Pi r squared, let me scooch it over a bit and up. All right, so let's do pi. I should have put 3.14, but that's okay. 9 squared. So we're going to do 3.14. Okay, you're going to do 9 times 9, and then times 3.14. And that comes out to be roughly, I didn't get an equivalent. Let me do that one in the calculator. 9 times 9 times 3.14. 254.34. All right. Now I want you to think of a lifesaver, the candy lifesaver. Okay. If you're trying to find the area of the lifesaver, don't you find out the area of the bigger circle around the outside and subtract out the whole? Okay. So to find the area of just the walkway, okay, we're looking for this. Okay, aren't we going to find the area of the, I should have done this in pink, sorry. Aren't we going to find the area of the whole thing and then take out the pond? We're not going to be tiling or bricking the water, the pond. You're subtracting that part out. Okay, so we want to find the area of the whole thing, but then we don't want to buy brick to cover the water. Okay, all right, so we're going to do area of the walk only is area of the pond plus walk minus area of the pond. That's the formula. Okay, so, and we already have them calculated here. So 254.34 minus 113.10. Let me pop that in a 141.24. And we're in meters squared. So here's our answer of the walk. And it says to write your answer in a sentence, I believe, on both of these, and I failed to do that on number 12. So let me go back and do that to both. Okay, the area that was felt by the earthquake was 7,850 kilometers squared. That's your answer in a sentence. Okay, and the area of the pond, area of pond is 113.10 meters squared, and the area of the walk only is 141.24 meters squared. Super important to understand, to find the area of the walk, you had to also find the area of the pond and the walk together. Okay, this is a key problem. It's very challenging, but I think you guys can do it. Okay, it may show up on your test. I will be thinking about that while we're studying distance learning. Okay, it would be if we were present in class. Okay, thanks guys.